Hello, everyone. Leif Jackson here, VP of Content and Community at Cybrary. Just so excited for our guests today. Uday Kamath, nice to see you.
Hi, my name is Uday Kamath. I work as a Chief Analytics Officer for Digital Reasoning and the author of the book Deep Learning for NLP and Speech Recognition.
Fantastic.
With my friends here.
Fantastic. James, you want to introduce yourself?
Sure. I'm James Whittaker. I also go by Jimmy, but
Jimmy works.
Either way, I'm easygoing. And yes, I'm actually a director of applied machine learning at Digital Reasoning, mainly focusing on speech recognition there.
Fantastic. And John?
Yes, happy to be here. My name is John Lill. I'm currently, founder and CEO of a AI startup. Previously, I was head of data science at Digital Reasoning, and that's where I met my compatriots here. So,
fantastic. Well, so excited to have you here. Would you mind just telling us a little bit about your book?
Yeah, I can start, and Jimmy and John can give more color. The prime reason was there were lots of tutorials. There were few academic papers. There were cookbooks in Python. There were cookbooks in deep learning. But there was nothing tying everything together in terms of what are the basics of machine learning needed. How do you go from machine learning to deep learning? What are the different areas in NLP that deep learning addresses? What are the different things in speech recognition that deep learning can enable you? And tying that together with practicality in terms of case studies, hands-on tools, techniques, the practical insights. So we found that there are pieces around, but there is nothing that puts them together. So that is how the idea started.
Gotcha.
Jimmy, John?
Yeah, just a couple of things that I would add. So it was a pretty heavy focus, even on the case studies and mixing that with the theory itself. So there were a lot of papers that would touch on kind of these theoretical aspects, but you wouldn't actually see much of the implementation itself, or you wouldn't see. Sometimes you would have exactly what Uday was saying, but the cookbooks, but they wouldn't actually go into great detail on what's important to focus on from a broader scenario from kind of a application rather than just theory.
yeah, and I would say I was very selfish, right? So I saw a gap out in the landscape where we had a lot of interesting projects that were applying very interesting ideas with very little theory behind it. At the same time, we had a plethora of papers. I mean, the amount of research has really exploded in the past few years in terms of innovative research, but very little of that research is finding its way into application. And so all three of us decided this was a perfect opportunity. Let's try to bridge these gaps, and actually let's write a book that can unite both the theory and practice and apply it to applications that are very novel, but really about to go mainstream. And that's why we came up with the book.
Interesting. Well, I'd love to hear some more about those applications, particularly in the cyberspace, particularly because that's a lot of our audience, right? Cybersecurity and IT, we have 2.5 million professionals all over the world, and they're very interested in this.
I would start with basic communications. Since speech and language, what the book is geared towards, touches the main aspect of communication. And if you see most of the cyber attacks or intrusions or insiders have some pieces or behaviors or anomalies that is related to communication, including things like phishing or
Sure.
Any of these behaviors starts with communications.
Yes.
So understanding what normal communication is, how these different human behaviors from attack perspective can start with natural language, with speech, with text happening on different data sources like chats, emails. And there, as John mentioned, there's lots of data. If you track a company's emails and chats and phones, it would be millions and billions of GBs. And to find out that interesting language or interesting speech pattern that can give you a pointer that this indeed is an interesting information, or this is different from what the person was communicating, or his voice sample doesn't resemble the CEO's voice sample, or the metrics here are completely different, is what you would need an AI system that can scale, that can learn, that can find these interesting patterns in the large volume.
Absolutely. And you have an extensive background in cybersecurity, correct?
Yeah. Previously, before I joined DR, I used to head the cybersecurity and fraud in BAE AI, and had more than 150 customers across financial institutions.
Wow. I used to work at a couple myself. I worked at Equifax, Barclays, and Capital One.
So if I could add too, right? So there's actually some very innovative concepts in natural language processing called embeddings, and really it's mapping words to embeddings that can actually capture structural and relationships between actual words, between actual concepts. This is actually a concept that's being applied in, interestingly, in malware. Mm-hmm. And what you can do is actually, some very innovative work in terms of building and learning embeddings of malware, and therefore identifying their footprint. And in doing so, you can actually probably increase the accuracy and probability of capturing some of this, basically entering within the firewall within the companies.
And many of the techniques which are related to deep learning, but not kind of constrained only to NLP and speech, are like transfer learning, domain adaptation, are kind of like what you can use irrespective of whether you are in computer vision or in security or any other field.
And it goes back that we wrote this book really to provide a foundation, an educational foundation for people interested in machine learning and then deep learning, and then the more higher concepts in deep learning, such as domain adaptation, such as reinforcement learning. And learning these concepts in the domain of natural language and speech recognition hopefully will set someone up to actually apply them elsewhere.
Yeah, just to follow along with that, I think there's a lot of kind of basics of kind of these machine learning and deep learning components that are in the earlier stages of the book that are really crucial in a number of ways. I mean, a lot of them get their grounding in computer vision and then have been adapted. Exactly what John was saying. The fundamental building blocks of it allow you to do things that can be like spatial relationships between either numbers or variables or different types of entities. I've seen some people use instruction sets as these kinds of input variables, or even learning sequential type modeling of if there's I've actually, a friend of mine has worked on this, but sequences of instructions very similar to some of these NLP tasks, but looking at what the relationships between these different entities are over time, and how you can model these things, and just actually be able to classify certain types of behavior or something like that. It's very similar to NLP in that regard.
Yep, and I think one of the most interesting chapter is on the reinforcement learning, and even though we applied it for NLP and speech, as Jimmy mentioned, reinforcement learning is that part of learning which is more AI than any other techniques, because you understand, just like humans, if you are following certain actions, how do you learn from that actions? How do you understand the policies or rules that have guided you through the actions? And whether it is a normal action or an anomalous action, like in malware attacks, you can train a reinforcement agent to actually understand, make it more explainable, and even have a policy-based system that guides you through that.
Absolutely. It goes back to say, language is very sequential based. A language is a set of sequences. When you actually can learn and identify a set of sequences, you can also do that in terms of actual malware intrusions. And so there's some very interesting concepts, I think, that will come out of NLP and be applied to as we speak now, are being applied to cybersecurity.
Absolutely. And are there, particular work roles in cyber that you think could especially benefit from the book?
Yeah, so I think, well, let me speak first. I think that obviously cyber security researchers will find the book very useful.
Yeah, absolutely.
At the same time, I would add that, especially with the case studies, I think cybersecurity engineers will find that, in fact, there's a lot of very interesting information, interesting code snippets that can be applied practically for some of their problems.
Yeah, I think you're right. Like researchers, data scientists, data engineers, we try to touch everyone through the book. If you have a data set, we have like a Dockerized service which can run through the Jupyter platform, like the entire notebooks, which have snippets of the code working really on the data, using the tools, using the libraries to give that practical understanding. And even though the data can be coming from the cyber world, they can just work on those case studies and see it live, understand it, and just modify things to their record and make it practical for them.
So what are some of the major skill sets that you would anticipate in the field that somebody would need, particularly in the cyberspace?
For these types of applications in particular?
Yeah.
So I think probably one of the main ones is just kind of an understanding of the data itself. So just usually whether this is either I don't know if they're just like kind of infiltration logs or whatever else they might be,
right,
but these types of things. But the understanding of the data is pretty crucial from the start. And then also some of the fundamentals of deep learning, in particular, on how you would structure a problem. For instance, is it a classification type problem? Are you trying to say this is a vulnerability, this isn't a vulnerability, or this is an attack, this isn't an attack? From that perspective, and how you would actually structure the components of the deep learning network to actually perform a task on something like that. And then I think another aspect that I would imagine is just kind of getting creative with it and seeing what things, or just kind of imaginative on what things could be captured in something like an embedding space. And so I don't know how familiar people are with embedding spaces, but essentially the idea is, at least from an NLP perspective, you have a sequence of words. You just turn each of those words into like a vector of numbers that represents the meaning that's derived for that word. And you usually learn that through looking at a lot of data, and given the context, you start to actually understand what the meaning and representation of that work is. So you start to learn things like, I know I'm tangenting off the question, but
no, it's fine.
You start to learn things like these types of instructions are usually seen in similar context, and therefore, but this one's only seen in the particular case of vulnerability. So then maybe you can start to classify some of those things. So I think it would be definitely a data science type of skill set is probably essential in knowing how to manipulate data and some of the caveats and some of the gotchas that can come in with that. But then also just kind of an interest in how you can structure something to learn the underlying representation and what you're really trying to target, and how to kind of tweak these building blocks to get there.
The number of tools in the toolbox is growing exponentially these days, right? So I think it's actually a very important skill to have, to actually figure out what's the right tool for the right job, or it's a sequence of tools. But what you don't want to do, and I've seen a lot of people do, is throw everything, including the kitchen sink, at a problem. You don't want to take a data set. You don't want to run PCA and then cluster it and apply it through a neural network. That would be what we would call overkill, right? So, and probably run over a couple of times. So, I think where students, as they gain more, vocation in this field, it's actually learning and understanding what tools are used for what techniques are, why are they used, how are they useful, when are they useful? Because you can actually short circuit a lot of time and a lot of resources if you actually throw the right tool at the problem. And so I hope that people reading our book will gain some of that insight, what we call practical knowledge. It definitely was one of the focuses in our book.
So in terms of data, right? So it sounds like, I mean, there's a lot of unstructured data out there. So how are some of the best, companies in the world, really structuring this data and using it to their advantage?
I mean, it is domain specific, right? The way healthcare is working, how to capture the patient records, how to capture the doctor notes, how to capture the pathology reports, and actually find interesting patterns across so that it helps whether finding certain things or automating certain stuff. So it has to start not from the data, but from what you're trying to automate or what you're trying to find, which is kind of the ROI or reducing your work. And once you have that fixed, then mapping it to a process and eventually to the data is what happens. So finally, the answer lies in the data, but you need to start from the top level goal of what are the things you are trying to automate, or what are the things you are trying to learn or predict or invent. And from that, what is the process normally a human would do, or you want a machine to follow, and then comes the data aspect of it. So healthcare would do it differently, finance would do it differently, traders and trading world would do it differently. Google, which keeps a record of everything that is going on from emails to processing of communication, does it differently. Amazon, which stores information in terms of what you are buying, what resources you are using, and what is your profile of buying things, keeps the data and mines it differently. So for me, it is completely dependent on who it is and what they are solving for.
Yeah, I think one thing that we kind of touched on towards the end of the book, maybe in the conclusions and future outlooks, is the way data is going to become kind of a key. I mean, it's already a key focus with most problems, but it's going to become a resource almost like the code itself. So there's kind of this idea, I know I get some eye rolls on this one potentially, but how software 2.0 is kind of the kitschy term for it. But how all software will eventually be learning-based in some way in the near future and machine learning-oriented. And so just like your code is versioned and you're tracking bugs and you're maintaining that code over time and doing these bug fixes based on that, the data is that you're learning from is then becoming a contributor to that code. So how you're tracking that and learning from it is going to be an iterative process as well. So, and this has a few different components to it, obviously, which is, the collection process that's probably the furthest upstream, the models that you're training, how that training data is changing over time, and then even the models and other types of things. We're also in the dawning of a lot of the deep learning stuff. So there's plenty more that's going to be coming out, and so the newer techniques that are obviously going to be used with the same types of data, or same data that you've collected, it's going to be reused for a long time. So just a lot of the things on that are going to be really interesting as they go.
So actually in our book, we actually do cover some of the more leading techniques in terms of semi-supervised learning, one-shot learning, zero-shot learning. These are techniques that are being developed right now, and really some of them have been developed in research specifically to address learning from small data, where you have only a small set of labeled data. Because the reality is in our world, there's a lot of unstructured data. There's very little labeled data. And unfortunately, it's very expensive to label, and there's lots of concerns about, how label, inter-annotator agreement. There's lots of issues with that. The one other trick that we have seen taking place in the industry is to, try to self-label. And I say self-label. There's actually a very interesting technique in language modeling, for instance, where we have a stream of words, sentence, and we try to use the previous words to predict the next word, because we know what the next word is.
Right.
But that word becomes a label then. And so if you think about sequences, you can take the ability to do that. Whether in, for instance, a lot of people are interested in blockchain markets right now. and again, in price prediction. Well, in fact, if you think about all the previous price history as user features to predict the next data point, you do actually have a labeled data set in that sense. Actually have too much labeled data. The last thing I would say is, people think language is an easy thing to train for computers.
Right.
Right? Or if you think about it, it takes a baby a year to acquire language. And before that, it took probably $800,000 of development, evolution, so that the neural pathways were set up for that baby to learn that language. It's a very tough problem. And so we deal with many ways, many things. Obviously, AI is AI research is evolving at a very rapid pace. There are still gaps, and so we encourage people to actually learn about AI because, in fact, you may be the one to actually fill that gap and create something very innovative.
That's fantastic. Well, I appreciate you guys coming today. I really appreciate it. Any last thoughts or words for the audience?
I think as Jimmy and John mentioned, this is the great time for people to take on AI if you are not already doing some form of AI, because from hardware, tools, data, resources, you have almost everything available to you. And with this book, we have tried to put all the things together and enable you to do that. So all the power to the readers and the podcast hearers to take on that. Thank you so much, Leif, for doing this.
Well, thank you for coming. Really appreciate it.
Yeah, thank you very much.